We've been working with several inequalities lately, and today we're going to be talking about compound inequalities. A compound inequality has two inequalities that are joined by the word and or the word or. And a big difference with compound inequalities that we're going to be looking at today is that when you graph them, they're going to be graphed on the same graph. So you're putting two inequalities on one graph. In example 1, we have an and inequality, and I know this because I can look at the inequalities here, and we've got 2 in the same problem that is sharing a common term in the middle, this r minus 5 here. It's being shared by both. So this is an and. They're joined together by the word and, even though we can't see it. In order to solve this problem, we're going to have to split them apart. So I'm going to start with this -4, and I'm going to take the -4 and the less than sign and connect it with our shared middle term r minus 5, and we're going to make that its own problem. So we're going to have -4 less than r minus 5. For the second one, we're going to take the -1 and the less than or equals to sign, and we're also connecting that with the middle term. So the second problem that we're going to be looking at is r minus 5 is less than or equal to -1. So we've taken one problem and we've created two with it, which means we're going to have two answers. So let's look at this first one. We're going to have to add 5 to both sides, and we'll have -4 plus 5 is 1. And we've said before that when graphing, it's easier to graph if our variable is on the left side, so we'll switch that around. And when we do, we've also got to switch our sign from less than into greater than. So we're going to have r is greater than 1. Our second one, we're adding 5 as well. And we'll have r is less than or equal to +4. So I have r is greater than 1, r is less than or equal to 4. Let's go ahead and graph the one in blue. To set up my number line, I'm going to start at 0 and make my way towards 4. And since this one is greater than, that means our circle for 1 is going to be open, and our arrow is going to be pointing towards the right. Okay. For the next one, we have less than or equal to, so that dot is going to be closed. And since it's less than, that means its arrow is pointing towards the left. If you'll notice, we have got some overlapping happening with our arrows. In between 1 and 4, our red and blue arrows have overlapped each other, and what this means is that the solution for this compound inequality can be found between the numbers 1 and 4. So any number I can choose that goes between 1 all the way up to 4, I can plug it into our original problem and get a true statement. And when we're graphing and inequalities, we don't even have to have the arrows over here. As you're drawing it, you can stop once you get to your dots. So at this point right here, this is what an and graph can look like. We've got our two dots and some overlapping arrows in between. So this is an and graph. Let's see what an or graph looks like. Example 2 is an or inequality problem, and that doesn't mean that we get to choose which one we want to do. We're going to have to solve both of these, but this is a little bit easier to detect what it's supposed to look like because we have the keyword or here in between them. Alright, solving the one on the left, we're going to be subtracting 3 first. And we'll have 4v is less than -8. We'll divide both sides by 4. And that gives us v is less than -2. So here's one solution. For the one on the right, we're subtracting 7. And I'll get negative 2v is less than negative 6. When I divide by this negative 2, that means my sign is going to change from less than into greater than, and negative 6 divided by negative 2 would be positive 3. So let's set up our number line here. I'm going to start at negative 3. And graphing our solution in blue, we're going to have an open dot on negative 2. And this time the arrow is less than, so we're going to the left. Our solution in red will also have an open circle on positive 3, and it's greater than, so that arrow is pointing towards the right. Our OR graphs end up doing almost the opposite of what our AND graphs do. AND graphs will point into each other and overlap. OR graphs point away from each other and don't touch at all. So this is one good determination for making sure that you're at least graphing them correctly here. And what example 2's solution on the graph tells me is that the solutions for these two inequalities are located less than negative 2 and greater than positive 3. The numbers that are in between these dots, if I'd plugged those in for v for both of these inequalities, it would have given me a false statement. So the solutions do not exist between the numbers negative 2 and positive 3. And this is just a reminder of something you may want to write down here. An AND graph will have arrows that overlap. An OR graph will have arrows that point away from each other. You will never have a compound inequality graph where the arrows are pointing in the same direction. So if you end up graphing something where both arrows point to the right or both arrows point to the left, then something's wrong and you need to go back and see what kind of mistake that you made. Make sure that you ask any questions that you've got while you're in class.